It's beginning to look a lot like statistics. Every school you go, take a look, oh, it's 12:10.
How does the transformation of a radical function change the domain? Well, the first thing you need to do is graph the parent function, the f of x. Then go ahead and graph the transformation of f of x, which results into the next graph called g of x. Number 3, calculate the domain in interval notation. So I just want to do a really quick review of interval notation. In interval notation, it looks like an order pair, but it's not. On the left side is on the left side of the graph. And whatever's over here, that is the right side of the graph. Now over here, I just made up an example. Let's just say this is your graph, the square root function. It starts here on the x-axis at 0, and that's why I have this 0, and then it goes towards positive numbers, which is called positive infinity. That's one reason why I have this one. Now, over here it says, with infinity, the parentheses basically means don't include. But with infinity, you will always use a parentheses, okay? Over here on my example here, if you will use a bracket, this straight edge one, when it is a closed circle, okay? And if it's ever an open circle, you will always use parentheses. Now, if you don't see a closed circle, remember every point on the graph is actually a closed circle. There's a billion of them on there, okay? That's a quick review of interval notation. So when you're doing the interval notation of the radical function, square root, or the cubic cube root, number 1, remember the domain is the x-axis, so only focus on the x number line, okay? Number 2, you're going to go from left to right. And number 3, you can use your pencil and go vertically from the left to the right, as like I'm drawing these lines. Now, keynote, it is not the vertical line test, okay? So that is the introductory as we do these transformations. Go ahead and graph the blue f of x there. And that graph just looks like this. Remember 0, 0. You're trying to pick numbers like 4, 2, and square root of 9 would be something like 3. Okay, you don't really need the points, but that's just the general shape. That's the big idea. Okay, here you want to observe some what's happening there. So you have this 2 there, and I'm going to go ahead and write the, I don't know, like kind of like the formula. And what I'm doing here is I'm just identifying the A, B, C's, and D's. So you'll realize, look at this, I'm not circling that negative sign, so C is actually equal to 2. So what is happening here is this is actually going to the right. Remember the silly phrase, add to x, go west or left? Do you guys remember that silly phrase? Well, how does that work? Right here, it's not a plus. It's not adding, so no. So you're not going left, you're going what? Right. So if I had a graph g of x, which is in green here, I'm going to graph that, you're just basically being shifted over here down to 2. And that's all you really need, okay? Now, what does that look like for my interval notation? Remember, if you draw the lines, you know, this time in black lines, you're basically only starting here on the x values at 2. And I'm going to write the 2 right below where the graph intersects the graph right here. Okay, and remember that's a closed circle, so it's going to be a bracket, comma, you can put the comma anywhere you want. And then remember over here, it's going to be positive numbers, right? It's a 4, it's a 9, so this is really positive infinity. And then there's my parentheses, and that's my answer, which I'm going to go ahead and box. Okay, so I kind of wanted to show you like right below it, because I want you to see that that 2 from the graph kind of falls down right here. And then infinity is like right there. That's the left side of the graph and the right side of the graph. Now, I kind of wanted to also show you the integral notation for the blue graph. It's starting here at 0, and it's also going towards positive infinity. And so that distance, let's see if I can find a really good color, like orange. This distance here is a +2. So you can see that the domain is only changed based off that x value. And I'm just going to graph x minus 4. And remember that phrase that's right above it. Add to x, go west or left. But right here, you are not adding to x. There's no plus x there. So the trick is that you are actually going to the right. So we can say c is equal to 4. You're going to the right 4 units. Let me prove that to you again. If you just have x minus c, notice the minus sign must be there so that c is 4. Okay? Okay, so let me graph the blue one. So that is to the right 4 units. And this is a square root function. Okay? That is the blue graph. That is f of x. Okay? Now this next one, g of x, is written a little bit funny. So if you can do something like this. It's okay. I'm going to write it as negative x plus 4. Okay? I just rearranged the order. The negative x went front first and then the plus 4. But if you rewrite it again, if you factor out a negative 1, you'll have negative x minus 4. Okay? And you'll notice that's actually the same exact thing. Let's see if I can use my technology here. I don't think I got it. Let's see. Oh, got it. Oh, yeah. Okay. Kind of. But mine's that little black line, which I can get rid of, I think. Yeah. That's okay. So what I'm trying to point out is that actually is your, that's your b value. Look. And what I'm trying to point out is that b value is a negative 1. So to go to g of x, if b value is negative 1, this is a reflection over the y-axis. So it's going to go, if you think about it, if this is 4 here, it's going to go 4 on this side. So the green graph is going to be at negative 4. So this is my new graph. And you could go to your graphing calculator and put those in and see that, but what I'm trying to do is if you recognize the letters and the characteristics, you can actually do this without it. So again, let me just quickly do the integral notation for the parent graph f of x, which is in blue. You'll notice that's starting at 4, so you have a 4 here, closed circle, it's a bracket. And then this is going towards positive numbers. So that would be the integral notation for blue. Okay. Now for the green, okay, a green pencil or something here. Okay, so you are starting, you know, if you're doing the black lines, right? The first thing you're starting there is at that arrow. And the arrow is implying from negative numbers, which we call negative infinity. And then my graph would actually stop there on the green graph at negative 4. So, if I can point this out to you, I just need negative infinity and negative 4. Remember, bracket. Okay, so this would be your answer. That is our new domain after the transformations. Go ahead and graph the blue f of x. And hopefully you guys noticed I'm trying to use lots of colors for you to visually see it. So again, this is the parent graph. Okay, so what's the difference between the two graphs here is just this negative. It's remember we asked that question before, is it in the inside or outside? Well, this one's in the inside. Is it to the left or the right? If it was the left, that would be a B value, and if it's to the right, that would be the C value. Remember, you can always write out this long parent graph, but you'll see that it's the B because it's to the left of the x, right? So essentially what you have there, you have a B value that is -1. And what that is that is a reflection over the y-axis. Reflection over the y-axis. Okay, so let's go ahead and graph g of x here in green. And this is my y, so basically we're going over this dotted line here. And it's going to go this way now. Okay, so let's go ahead and get interval notation for g of x. You can remember, we're just focusing on the x number line. So I have negative infinity and positive infinity, and you're just going from left to right. So left, nothing, nothing, nothing. Okay, the first thing it's hitting is this arrow. The arrow is saying negative. Pen will turn off. Negative infinity, and with negative or positive infinity, you're always using a bracket. And then the graph actually stops there on x equals 0. And remember, it is a closed circle, so it is a bracket. Okay, so that is our answer for the after the transformation. And you can kind of see what happens. Let me show you the other one. The other graph, let's use yellow lines. You know, you're starting here at 0. That would be a bracket, and then you're going in this direction. The last arrow you're touching is positive infinity. So this would be the answer for the domain for the original parent graph. Let's go ahead and graph this one. This is a cubic because cube root because you see the 3 there. And if you guys remember the reference points, 0, 0, 1, 1, and then 8, 2. And -1, -1, and -8, 2. So this is the general picture of the graph. Remember, it's the inverse of the cubic function, so just really our cubic function rotated 90 degrees to the left or counterclockwise and then reflect over the y-axis. Okay, what's different about the two graphs? Well, I noticed this -3, so let's go ahead and highlight the -3 here. And I noticed that it's on the inside. If it's in the inside, it has to be either a B or a C value, okay? And if you get stuck, you can always just write it below. And you'll notice that's towards the right of the X, so it is not a B value, but a C value. Okay, here's the question. What is my C value here? Okay, I'm gonna zoom in. If I can make it super clear, the subtraction sign must be there. So your C value is going to be a +3. C equals 3. Okay, if you look back at your notes, this is going towards the right, 3. Remember the silly phrase, add to X, go west. But are you adding here? That purple, is that adding? Are you going west or left? No, that means you're going to go right. Okay, so let's do that in green. Let's go ahead and graph g of x. We just need to shift all these points towards the right. And you don't even need to, you don't have to do much. Just kind of remember the parent, right? But it's more just, it's a visual for you. That's all it is. Okay, so let's go ahead and use interval notation. And hopefully you remember, you see these 2 arrows. Okay, look at the green. Let's do the green. You know, if you're going in this direction, the first thing you'll touch is the arrow, which is -infinity. And if you get going on, then the last thing you're touching on the graph is the arrow, which is +infinity. So the domain for the f of x would be negative infinity to positive infinity. And remember, it's as easy as this, guys. This one's easy because it has two arrows, right? There's an arrow in green here and an arrow over here on the right-hand side. Let's do the blue one. Same thing. As you're going, the first thing you're touching is, it touches your graph, is this one. Now, again, it's on the x-axis number. These numbers, -5, -10, I'm going to call this -500, they're negative numbers. And when we say all the big negative numbers, we just call that negative infinity. And as you go towards the right in blue, for the blue graph as well, that's the same thing. The last thing you touch is this arrow, which is pointing towards, on the x number line, you're going towards really big positive numbers like 1,000, 10,000. So we call that positive infinity. So the transformation actually does not change the domain, but that is your answer for the domain for your second function after the transformation. All right, let's graph this one. This is the cubic function, but the d value is 5, so that's going to go up 5. So originally the graph was something like this, right? And I can do something kind of cool, I think. And basically it's shifting up 5 units. Does that make sense? And here's a cool thing. Let's see. Duplicate. And this one is, can I change the color too? Boom. Oh, that was so cool. Sorry, that was the first time I've ever done that. And that's -5. So they're essentially the same graph. Draw these arrows. And just like the last problem, the blue has a domain of negative infinity to positive infinity. How did I get that so quickly? They're both going to be negative positive infinity when you have 2 arrows. Okay, look at this one. Same thing, 2 arrows. These are coming from negative numbers, right? There's a graph, there's numbers, there's numbers, all the way to this arrow, which means you keep going towards positive numbers. So that's also going to be negative infinity to positive infinity. So, is that true for all of them, Mr. Ring? That is right. Wow, look, let me show you guys a super easy one. A linear function, right? Arrow, arrow. It's still going to have the same domain, okay? So look for those 2 arrows. That'll be super helpful. See you guys. All right, E6. The graph of the blue, f of x, is just the parent function. And it looks something like this. Okay, so that's blue. Okay, green, what's the difference for the green is you have this negative sign. What does this one do? That is your b value that's -1. So when the negative sign is inside, or you can take the grayscale factor, what's inside the radical, that is a b value because it's to the left. What this one does is it reflects over the y-axis. So what we've been working on is characteristics to letters or letters to characteristics, right? And here's my y. So my graph now is going to bounce over that one. Let me get some reference points, really dark, so you can kind of see these. Let's do my color purple. So each of the points now are kind of going across, right? So this is my new reference point. Way here to there, it's going to go same thing. This one's going over the y, the red dotted line here. That one's going over here, okay? So our new graph in green is going to be looking something like this, okay? Okay, so we have from the blue to the green reflects over the y-axis. Okay, question. Did the arrows change? You have 2 sets of arrows. So in blue, the domain, blue, pencil dying, the domain is going to be, again, arrow coming from negative numbers all the way to over here, which has positive numbers. numbers. So that would be positive infinity. Remember, we talked about it. Anytime it has two arrows, it's always going to be negative infinity to positive infinity. Another way of saying this is all real numbers. You can pick positive numbers or negative numbers. Let's do the green. The green is the same idea, right? I start over here. It hits my graph. It doesn't matter if it's above or below. What matters is that it's coming from the left side, right? So that would be a domain of negative infinity. As I keep going, the graph keeps touching. So I want to know where the graph stops. Well, it stops here at the arrow, and it's not negative infinity. This is a common mistake for students because they think it's below the x-axis. Again, the point is that you have so let's just say I make up an order pair. Let's say this order, it's kind of hard to see. Let's just say here my order pair is positive 10 and then negative 10. The point is it's going towards x values. Domain is x values. So the graph's going to keep going with that arrow, so it's going to be positive infinity. So actually, the domain does not change with this transformation. And that is your answer for E6.
On the 12th day of math, Miss Mr. gave to me 12 packets scanning 11 discriminants 10 parabolas 9 xboxes 8 times table 7 vertex form 6 y-intercept 5 expressions 4 fx functions 3 practice tests 2 wag forms and the axis of symmetry.